need to intercept every single message flowing through your FastMCP server, regardless of type, without writing separate handlers for tools, resources, and prompts. You'll see how to create raw middleware that taps into the complete message pipeline, logging every operation from start to finish. The pattern uses the base call method to catch all requests, then delegates to the next middleware in the chain, giving you full visibility and control over the entire request lifecycle.
From FastMCP server middleware, import middleware, middleware context. Class raw middleware, middleware. Async def call, self context. Middleware context, call next. Hash this method receives all messages, regardless of type. Print f raw middleware processing, context method. Result equals await call next, context. Print f raw middleware completed, context method. Return result.
This demonstrates the interceptor pattern applied to Model Context Protocol, MCP message processing. The middleware acts as a transparent layer that wraps core server functionality, allowing you to inspect, modify, or augment requests and responses without altering the underlying components. What makes this distinctive is its non-invasive nature. You add cross-cutting concerns like logging or authentication without modifying the tools, resources, or prompts themselves. The pattern works by creating a pipeline where each middleware component receives the context object and a call next reference. This enables both pre-processing, before the next layer executes, and post-processing, after receiving the response, with full control over whether to continue the chain or short-circuit it. The design follows the chain of responsibility principle, where each middleware decides how much to handle and what to delegate, keeping concerns cleanly separated. This approach solves the problem of scattered cross-cutting logic in MCP servers. Instead of embedding authentication checks in every tool or manually logging each operation, you centralize these concerns in reusable middleware components. The trade-off is a slight increase in abstraction, but the benefit is dramatically cleaner component code and the ability to modify behavior globally by simply adding or removing middleware layers. Let's break it down line by line.
From FastMCP server middleware, import middleware, middleware context.
Imports the base middleware, class, and its context type from FastMCP's server middleware system. These provide the interface and request context needed to create custom message processors that intercept and modify server traffic.
Class raw middleware, middleware.
This defines a middleware class inheriting from FastMCP's base, middleware. Middleware intercepts and processes messages in the request-response pipeline, enabling cross-cutting concerns like logging, validation, or transformation. The inheritance ensures proper integration with FastMCP's middleware system.
Async def call, self context. Middleware context, call next.
This implements the middleware callable interface using call as an async method. The context parameter carries request metadata, while call next passes control to the next middleware in the chain, enabling the pipeline pattern. This is the standard FastMCP middleware signature for intercepting and processing messages.
Hash this method receives all messages, regardless of type. Print f raw middleware processing, context method.
This is middleware's universal message interceptor. The comment clarifies it processes all incoming messages regardless of type, while the print statement logs the method name for debugging. This pattern ensures visibility into every request before specialized handlers process it.
Result equals await call next, context.
This delegates processing to the next middleware in the chain using await call next. Middleware pattern. Each layer processes the request before and after passing control downstream, enabling pre-post processing hooks. The await ensures proper async execution flow through the pipeline.
Printf raw middleware completed. Context method.
This logs the completion of middleware processing, mirroring the initial print statement to create a clear execution boundary. The method name in the log helps trace which operation completed, essential for debugging async call chains. This bookend pattern ensures visibility into middleware lifecycle without modifying the context or result.
Return result.
This returns the processed result from call next, maintaining the middleware chain. Without this return, the pipeline would break, preventing downstream middleware and the final handler from receiving the response. It's the standard pattern for middleware to pass through results while optionally adding behavior before and after. FastMCP raw middleware pattern. The call method in FastMCP middleware intercepts all MCP messages regardless of type, giving you complete visibility into the request-response cycle before and after processing. The middleware chain executes in reverse order during the response phase, so your pre-processing logic runs first, but your post-processing runs last. This pattern enables cross-cutting concerns like logging, monitoring, and request transformation without modifying individual handlers.
The middleware that sees everything becomes invisible to everything.